3.5, composition of functions. Composition of functions. The composition of a function g with a function f is, this is an h of x. H of x equals g of f of x. The domain H is the set of all x values such that x is in the domain of f and f of x is the domain of g. So we're essentially inserting a function into another function to create a new function. Okay, in general, f of g of x is not equal to g of f of x. So let's take a look at some examples. Substituting expressions into functions. Let f of x equal 4x minus 1 and g of x equal negative x plus 6. We are going to find the function f of x plus 5. So that means we're going to take the f function, 4x minus 1, and we're replacing the input with x plus 5. So now we have 4 times x plus 5 minus 1. Then we just simplify this with the distributive property. And we get f of x plus 5 equals 4x plus 19. Let's try the next one. G of 3x plus 8. That means we're going to take the g function, which is negative x plus 6, and we are replacing the x with 3x plus 8. So then we have negative 3x minus 8 plus 6, and that simplifies to negative 3x minus 2. So g of 3x plus 8 equals negative 3x minus 2. Okay, number 2. Let f of x equal 2x minus 7 and g of x equals x squared plus 4. What is the value of g of f of 3? So we are going to start, you can do this a couple different ways. I'm going to start by writing the g function because that's the outer function, but I'm inputting f of 3. So where I see the x, I'm replacing it with f of 3. So I'm just going to use empty parentheses to get started. So g of x equals x squared plus 4. But then it says now we're going to take the f function and put that into the input. So 2x minus 7. But again, instead of the x, I'm using parentheses because x is 3. And now we can go ahead and simplify this using our order of operations. 2 times 3 is 6. 6 minus 7 is negative 1. Negative 1 squared is 1. And we get 5. So there's our final answer. We can just put a box around it, that's fine. In number 1 I wrote it, said equal to what we started with. But in number 2 I'm just going to box the answer. So that's one way you could work through that, just going through the outer layer and slowly putting everything into its correct domain area. There's another way you could do this, and it's really personal preference, whatever is easier for your brain. So I started with the outer function and worked my way in. We could also go the other way. We could take f of 3 and do that first. So f of 3 would be 2 times 3 minus 7, and that's equal to negative 1. Then we could take the g function, and now we're going to do g of negative 1. So the g function says negative x plus 4 okay, so I worked on the inside and I worked my way out, and then that gives us 1 plus 4, which is 5. So those are the two different ways you could work through a problem like this. It does not matter which way you go, just make sure you're paying attention to what function you're using and what your input value or input expression is. So now we're going to practice with just the functions themselves. So when I work with just the functions of themselves and not evaluating a numerical value like we just did, I'm going to start on the outer function and work my way in. So let's see what that looks like here. So we have f of x is negative 2x plus 5, and g of x is 5x minus 2. Letter A says we're going to do f of g of x. So we're doing the f function first, but my input, the input value, is changing to a new function. So I'm going to write negative 2, leave space for my g of x function, plus 5. So I wrote my f of x function, and now my input into that is the g function, 5x minus 2. Once that composition is done, then I can simplify. So we're going to use the distributive property. And we get negative 10x plus 9. Box it so that we don't have to play Where's Waldo with our problem. Okay? Go ahead and pause the video, and I want you to try B, C, and D. And then when you're ready to check your work, resume the video and check to see if your answers are correct. Okay, letter B. So for letter B, we're doing the g function first. So I'm going to write the g function, which is 5x minus 2. So 5x minus 2. Okay. Then the domain is the f function. F of x is the domain. So the f function is negative 2x plus 5. Once my composition is done, I can now simplify. And you can see that for A and B, we did not get the same answer, which just shows proof, algebraic proof, that f of g of x and g of f of x will be two different results, typically. All right, let's go to letter C. We're using just the f function this time, f of x. So I'm going to start with writing the f function, negative 2x plus 5. Negative 2x plus 5. But my x is now f of x, so negative 2x plus 5. Simplify. And we're done. All right, letter problem D, g of x. Now we're working with just the g function, 5x minus 2. So the g function is 5x minus 2. The x now becomes the g of x function, so 5x minus 2. 5 times 5x is 25x. 5 times negative 2 is negative 10. Simplify. And we are done that example. Okay, let's move on to the next page. Actually, that was it, because guess what? 3.6 is inverse function, so we will do that tomorrow. There are your 3.5 notes.